Today, I'm going to talk to you a little bit about the law of sines and show you how to label a triangle and how the law of sines works. So, up until now, we have been using triangles that have a right angle in them. Today, we're going to look at triangles that could be acute or obtuse triangles. So we have A over sine of A equals B over sine of B equals C over sine of C. So as we know, the input of a sine function is an angle. So capital A, capital B, and capital C are all angles. Now, it doesn't necessarily matter which order you label these in, but I'm going to do them like this. So here is capital A, capital B, and capital C. Now, in the very first lesson of this year, we talked about how the shortest angle is across from the shortest side. And likewise, the largest angle, I should have said smallest angle, the largest angle is across from the largest side. So, with that being said, side lengths A, B, and C are across from angles A, B, and C, respectively. So here's angle A. If I look across from it, that'll be side A. Notice the side has the lowercase. Here is angle B. Across from it is side length B. Angle C, across from it, side length C. So when we're using the law of sines, it is extremely important to notice in order to have one full part to complete a ratio, you need an angle and a side across from each other that work together. Now, sometimes you're given two angles. We know that all of the angles in a triangle add up to 180 degrees. So if we know two, we can always find the third. So anytime we're given two angles, we can always find the third angle by adding them all up and making sure they add up to 180. So I am going to do an example problem with this. I just need to make sure I have a calculator handy, and I do. So I'm just going to draw a triangle first. I'm a very visual learner. I like to draw triangles first. So it doesn't necessarily matter if you draw it to scale. Here is my triangle. I'm going to call this C, and that is 102.3 degrees. I don't have the side length across from it. I have angle B, which is 28.7. And I have the side length across from that, which is 27.4. So what's really important to notice here is that I have side length B and angle B, which completes one ratio. So from that, I can do 27.4 over sine of 28.7 equals. Now, my other part that I have started is C here. So I can do I'm missing C, and I have the angle, so over sine of 102.3. So this is side length B over sine of B. Side length C I'm missing over sine of angle C. So now when I have two fractions equal to each other and I'm missing one of the parts, I can do cross multiplication. Or looking here, in order to get C alone, I can multiply by sine of 102.3 on both sides. Some of you might prefer to do cross multiplication and do this times this equals this times this, and then you end up dividing. Either way, you're going to get the same answer. So I'm going to go over to my calculator. And I'm typing in, making sure it's in degree mode, 27.4 times sine of 102.3 and I get 26.77 continuous without hitting the clear button. Now I'm dividing by sine of 28.7. And I'm getting 55.747. And that is in feet. Now, it makes sense. This is a really important thing to recognize. It makes sense that this side is longer than this side because the angle across from it is larger than the angle across from this one. Very important detail to notice. So this is one side length, sorry. So now I am missing angle A and side length A. Now we've already kind of talked about how I can find angle A quite easily. If I have two angles, 102.3 plus 28.7. I get 131. Which gives me 180 minus 131 is 49 degrees. So that tells me angle A is 49 degrees. Now I can use the law of sines again in order to solve for side length A. Now I'm still going to use B over sine B because these were given, and it's going to get me a more accurate answer if I use my given parts rather than just using what I just rounded. So I'm going to set that up again. 27.4 over sine of 28.7 equals side length A over sine of 49. Now, in the interest of a lot of people like to use cross multiplication, I'm going to show you what that would look like. 27.4 times sine of 49 equals A times sine of 28.7. And then I'm going to divide by 28.7 on both sides. Sine of 28.7. So now I'm going to get side length A equal to, and I'm going to do that on my calculator. So I'm getting sine of 49 equals 0.7547, leaving that in, times 27.4 equals 20.679. And then I'm dividing by sine of 28.7. And I'm getting 43.061. So at the end of one of these problems, you should have all of the sides and all of the angles filled in. And this was angle A. So in the end, you were given 3 pieces of information, and I have 3 pieces of information that I found. 1, 2, 3, 4, 5, 6 works out. So now let's just test to make sure that this makes sense. 49 degrees is between 28.7 and 102.3. So this should be the middle side length, the middle length. So this is more than 27.4 and less than 55.7. So that actually all makes sense. So there you have it. We've just solved this triangle, which means finding all of the missing side lengths and angles using law of sines. Very, very, very important to note, you use this when you do not have a right angle in your triangle. So I don't have a right angle here. I never got one. This is how you can solve using trig when you don't have a right angle.